Hi again. In this part 3 of 10 concepts to know about AI, we are going to look into these questions. What is training in machine learning? What is training, validation, and test data set? What is scoring and predictions? What is supervised, unsupervised, and semi-supervised machine learning? How to calculate the performance of machine learning results? What is feature engineering? What is automated machine learning? And finally, the last question is what is machine learning interpretability or MLI? So let's go ahead and look into very first question. What is training in machine learning? So far you have understood is that training is very important and integral, and finally the very first step of machine learning process. You have a data set which you really start with. So your data set is your source or the source information, and any machine learning process which is using any machine learning algorithm or engine which really work on its input data set, learn from it, and finally generate a model, and that model is used to predict or to generate predictions. So training data set is really very important. And the training is basically a process where you are giving the data to a machine learning system, and an algorithm is really applied on the given data and learn from it. So what training does, it's really algorithm is really looking to the data set, finds the pattern in the relationship in the given data sets, and then understand it and compose all that learning into into a mathematical representation, which we call it model. Training is done for all kinds of machine learning process, whether it's a classification, clustering, regression, deep learning, everything. So training is really very integral part of machine learning process. Okay, the algorithm which is applied on the data set has the ability to find the pattern and relationship, and that pattern matching or understanding pattern and the relationship is all implemented within the algorithm. So if the algorithm is using neural network, the relationship and the patterns will be matched based on a neural network methods. If the algorithm is designed to use a statistical machine learning methods, then algorithm will find patterns and relationship based on statistical methods. This all depend on how the algorithm is really being implemented, and that's how the training process will be completed. Our next question is what is training, validation, and the test data set? So we understood that training is done on training data set. Okay, it means the data set which is used for training is considered the training data set. However, the way we really look into the training, because within the training we also need to do the evaluation. So we train the data, we try to do the validation, and that while we do the validation, we really need to understand how good our training is. And the training and validation process is really keep moving, keep going along until we really achieved a state where no longer learning can be processed, or maybe learning could be done in a way that finally it's actually try to start memorizing the results. So during the training process, there are three. For a machine learning process, we really use three different data set. One we call the training data set, second is validation data set, and finally the last one is the training test data set. The validation data set is a part of a data set which you try to set aside a small percent of your data, which you could do for validation during the recurring training process, where the steps by step the training is really being done. We also look into something called cross-validation a little later, but for now, we will just stick with the training, validation, and test data set here. So a training data set, which is the actual data set which is used for machine learning, and as a basic rule of machine learning process, we try to keep the about 80% of original data set as a training data set. The validation data set is a data set which is used for unbiased evaluation of results during the training process. So when the training is done, it's iterative training, means training is done step by step by step, and every step training happens, system learn, and there's evaluate, and then keep moving further and further and further. So about 10 to 20% of the data set is really being kept aside for validation. So these training and validation data sets are used side by side during the training process to understand, to learn from data, and then evaluate, and then keep progressing further. Finally, the test data set is used to provide an unbiased evaluation of the final model. When the training is completed and finally you do have a model, you really want to understand how good the model is, how accurate the model is, what is its accuracy. Then you apply the remaining 10%, around 10% of your original data set, which a machine learning system has never seen, and that data set is really being used to understand, is used to understand the accuracy and performance of the model, so that it can really, whether it can work in a real scenario where or its really results are not good enough. So that's the reason we are using training, test, and the validation data set. Our next question is, what is scoring and what is prediction? So let's look into prediction. So what is the prediction? The prediction is the result of a machine learning model after that model is applied on new data. Okay, so you have processed processed a whole machine learning a system where you gave input data, and finally your model is generated. Now you are using this model to apply on a new data, and the results you are going to see is the prediction, whether it's a classification, regression, or clustering. Whether this new the new data set is really telling if somebody is going to have a certain disease or not, what will be the house price, or where this new row belongs to which particular cluster of or a group of the information. That's all are considered as a prediction. And scoring is a process to generate the prediction. So we say that we are performing the score. Scoring is a process where we really try to apply the model on giving a new data set, and we generate the predictions. Okay, so a machine learning model is used to score the process, okay, and then generate the output. And the requirement for prediction is that when we are applying the machine learning model, the input data or the new data should be similar, or usually it must be in terms of definition. The prediction has to be done on the data set, new data set, which is exactly the same where the training came from. However, with the advance of machine learning systems, the similarity is the best word to use here, because if certain data set, certain aspect or certain features of the new data is different, the machine learning model can adjust up to certain extent, not completely, but up to certain extents they can be managed. And once the scoring is completed, then predictions are done. So scoring could be as for a new record, it could be a collection of records, or it could be thousands and millions of records. So scoring process is very vast. It's all depend on how the model is used and in which scenario it is used. In our next question about what is supervised learning, we start with saying is that in this supervised learning, we already, when the data is given, the data already comes with the answer or with the target here. Here you could see is that if we have an example of house price prediction or house price data set, where after providing house location, size, number of rooms, and the bathrooms, and which year house was built, what is total built size, as well as the lot size, we are providing house prices as well. In that scenario, the inputs are given, and the output or the target variable is also given, which has the relationships, and output variable has a relationship on the input variable. And this whole historical data set is really given to a machine learning problem where our objective is to predict the house price. Then this whole scenario is considered as a supervised machine learning. In this method, you actually provide a correct answer for the problem to begin with, and that having the correct answer is really make this machine learning process to learn the relationship between the input variables for the output. And when a new data set is given, that learning is applied on new data set to predict the output or the target value which the model is really learned after using the input data set. So in supervised learning, you always start with a data set which already has the target variable, or target or output variable. So supervised learning is a process to learn from the given input variables to understand how the target value depends on various inputs. So it could be a house price, it could be a class, whether somebody is going to have a certain disease or not, or whether an item belongs to a group A or group B or group C or group D, depending on how many classes you have. These are all various examples are part of supervised machine learning. Okay, once learning is completed, you can use supervised learning to predict the target value by asking the same or similar kind of input you have used to train this machine learning model. So that's essentially supervised learning. Most of our examples we have seen in this world are coming from supervised machine learning. Like if you the face recognition, if you are trying to identify if the image belongs to a certain class or not, whether this is a dog, this is a cat, or this is a car. These are all the great examples of supervised machine learning, where you start the training by giving the actual results and input, and then finally you do not have the actual results, but you do have the input, and you really want a machine learning model to predict what is the outcome, what will be the possible results. Our next question is, what is unsupervised learning? Unsupervised learning is a machine learning process where we start with a data set which does not have a target variable associated with it. And there are several business examples we could consider here when the data set may or may not have a label to really start with. A banking data set example, for example, where we have very billions and billions of rows about financial transactions happening around the world, and you really do not know which one is good, which one is bad, which one is fraudulent, which one is not fraudulent, which one is really correct one. And you start the process of you needed a process where you can apply a machine learning process, a machine learning method on the data set, so it can group the certain information in a way that you can later identify what that criteria of that collection was applied, so that you can really have a good understanding of what kind of information you really got in that certain group. So clustering is a very popular example of unsupervised learning. And what happens with clustering is that you really start with a data set where you really do not have output variable. So really you are not trying to find the relationship between the input and output, versus you are trying to understand the relationship between all the input variables, and based on relationship the algorithms come up with a certain criteria so that it can group a certain rows of information in a group, and it can group and it can create a cluster of information. Sometimes you, depending on algorithm, you can define the number of clusters you are really you would like to have that information grouped into. Sometimes you can let machine to find out what's the best size of cluster size it can really come up. So there are both way you could come up the number of clusters, or you can let machine learning algorithm to really decide the number of clusters can come up. Various examples we have looked, such as data compressions, dimensionality reduction, is really considered as unsupervised learning, unsupervised machine learning examples. Outlier detection is also a very important aspect of unsupervised, and sometimes you have a very small or very faint signal of the information in very large amount of data, and you can use unsupervised machine learning to really understand and figure it out if there is a group of records which really does not belong to the overall record set or overall data set you really have. Deep learning has the encoders and those autoencoders. Those autoencoders are really one big example of finding outlier from your data set. And this for unsupervised, you can use neural networks, you can use statistical machine learning, and both methods you could use to really apply in your large targetless data set to really come up with the results. If you look into the examples or a popular algorithm which are really used in unsupervised, we could say the k-means, hierarchical clustering, or the probabilistic clustering are very popular methods of clustering the data. For the data compression or the dimensional reductions, we have already looked at PCA and GLR as a very popular algorithms. The next question we have is, what is semi-supervised learning? Semi-supervised learning is a combination of supervised and unsupervised learning, and there is a way we could see scenarios and the examples of semi-supervised learning where it could be applied. Sometimes what happens is that we have a very large amount of data, however, a very small size within that large data set is labeled, and remaining data set is really not labeled. So we really needed a process or a machine learning process which can identify those a probabilistic label, maybe a certain label probability, and come up with an answer to those empty labels. So this way you could get the labels in your empty data set, and when your full data set has labels, then you could go ahead and then you can perform the supervised machine learning on that. In that scenario, you could be using a semi-supervised machine learning process. So what you do, you start with unsupervised method and you apply the unsupervised method on that given data set where you do not have the target, and that unsupervised method really come up with a way to put the target, or maybe it's basically trying to group the information in one way or another, and those grouping is what generate the target value. And this way your whole data set is really being labeled, and once your data set is labeled, then you can apply any supervised algorithm on that data set and then come up with the model what you are really looking for. Sorry, there is a mistake. It's supervised, it should be, which I will fix it. So that's was the so we have gone through with supervised, unsupervised, and semi-supervised learning. And now our next question is how to calculate the performance of machine learning results. Previously, we have seen the use of training, test, and validation data set, in which the test data set was really used on a final model or to check the accuracy of your model. In this scenario, we are also looking into say, okay, what was the performance? What is the how you can really understand the performance of machine learning result? Because now we have understood the clustering, supervised, unsupervised, all variety of machine learning terminology. So performance of a machine learning process is very important, because if you really know how good your model is, what is performance, you can apply that model into a business process. And the key stakeholder who really are really responsible to deploy this whole machine learning pipeline, they really can have a confidence on the results which are coming out from a machine learning model. So performance is depend on what kind of machine learning process you are really using. Because remember, if you are using clustering, you really look into the performance very differently versus if you are using a classification, or if you are trying to do the regression. Because depending on what your outcome is, you really try to look into the performance criteria in that way. So for that reason, depending on what is your supervised or unsupervised method, various performance matrices are available. Some data scientist, some machine learning engineer would prefer a one matrix over another, and all of these metrics are defined based on certain mathematics or stats is a concept behind them. And if one way or another, the performance metrics could be interchangeable, not in every case, but in some cases, most of the cases they are. So if a performance metrics for regression is 1, and then if you want to look into another number, you can use a certain math to apply on those metrics, and you will get in the result in a different matrix. So classification, if you are working on a 2 class, a binary class, then you can really understand that what the results are, how accurate are. And that's why you have a matrix called AUC, which is under the area under the curve. And then if you have higher percentage, it means your good results are positive results are very high. So same thing, we can look into the regression, where we look into the MSE, like mean square error, or root MSE, or MAE. Those different metrics we can use, and we can really understand the value in it, and then higher or lower value of these metrics are really considered to explain the performance of your machine learning model. We also look into other information such as variable importance to really check the performance of the model. Because if you understand your data very well, and if a certain feature is really stands out as a highest input as input for machine learning performance, then you can also trust that, okay, this machine learning model is really performing really very well. And there are, besides variable importance, there are other tactics machine learning and machine learning engineers and data scientists really use to evaluate the performance of machine learning results. After that, our next question is, what is feature engineering? If you look into internet, you look into the various information coming out in data science, you will see that feature engineering is really very hot topic and considered as one of the top talent for a data scientist or a machine learning engineer to use. So why it is? The objective for machine learning process is to improve the result. You really want your machine learning process to be highly accurate. So how you could do it? There are various ways. You can use different algorithm, you can use different hyperparameters, you can fine tune, you can do variety of things. However, your input is data. It means besides using the various algorithms, various engines, various machine learning pipeline, if you can spend a lot more time on your data, and if you could come up with a data set which is highly informative, you can make your machine learning performance or machine learning accuracy to improve very high level. And that is what the objective of feature engineering is. In feature engineering, the inputs, which are the features, you re-engineer them in a way that the information is given to a machine learning process is super rich. And the very good information, very rich information is what plays a very important role to improve the accuracy of your machine learning model. And so feature engineering is basically a data transformation. It's a very domain specific, because if you look into a data, it has two separate aspects. One are feature. If you look into a log, which has its own identity. If you look into a financial transaction, it has its own identity. If you look into a house price data set, which has its own identity. What is inside the data set? There are features. So numbers will be there, categories will be there, and there will be real numbers, there will be numerics, there will be category, there will be some classes. In some columns, some features will have few classes, some features will have thousands of classes. So that's a feature specific data view of data set. The other view is a domain specific, like a looking in data from a domain perspective, like a banking data set, like a retail data set, like a system data set. So feature engineering is very dependent on a domain specific expertise as well as the feature specific expertise. If you know the age, if you know a feature which is age, you really know how you can augment more information to the age feature, and then you can make it more and more information rich. Same thing, you could play with the date of birth, you can play with the date, you can play with a number which could be a real, you can augment more information to that. So those things are very important for a data science pipeline. And automated feature engineering tools are already coming into the market, which can apply a domain specific or feature specific feature engineering to data, and then improve the results just by applying those automated features. So after feature engineering, our next question is, what is automated machine learning? So automated machine learning, or AutoML, is the automation of various machine learning processes. A machine learning process where you have data input, then you are processing the data, you are doing feature engineering, could be automated way, and then finally you are applying various algorithms to it, and then you are evaluating the performance of your machine learning model, and finally you come up with the best available model. So these are the different processes of a machine learning pipeline. And if you are automating these processes, either all of them, one of them, that is considered as a automated machine learning or AutoML. The objective of automated machine learning is to expedite the machine learning process. That's a one. Second objective is that add or give the added advantage to a less experienced user or a data scientist or machine learning engineer, because using automation you can make a beginner as an expert by just automating several processes, and then just trying to come up with a automated strategy based on input data, based on variety of learning you have really learned in the past and you applied into a software. So there are so many things could be done, and now companies such as H2O, Google, Facebook, Microsoft, these are providing some kind of automated machine learning tool which can do the machine learning pipeline, which can build the whole machine learning pipeline for you in really very small to very insignificant amount of time. The steps in automated machine learning could be various. It could be selection of various algorithms, applying various parameters to the various algorithms, look depending on which range they are applied to, and find what is the best fit value will be by evaluating the models on validation data sets. Automated feature engineering depending on data and domain specifics, that is also part of automated machine learning, and then auto validation of the results. Rather than building a full model and validating, you can actually build a very small partial model on a very small subset of data set, and you really see that whether that particular feature or collection of feature is really working or not. If it's working, then keep it, otherwise drop it. So those things are also part of automated machine learning. H2O has a product called driverless AI, which is a very shining example of automated machine learning, which really a beginner or a very expert data scientist, they both can use, and it adds up more value to each one in very different way. It can make expert data scientists to do things in super fast way, so that he or she can really spend their time to do some other important job, versus for a beginner you can really start a machine learning process in very highly skilled way, and that is an added advantage for a user. So automated machine learning is very powerful, very useful, and used in a variety of ways to expedite the various aspects of machine learning process. Our final question in this segment is what is machine learning interpretability, or MLI. So MLI stands for machine learning interpretability. People are calling MLI in other ways, such as explainable machine learning, or some an explainability in machine learning, and other ways. So why it is important? So what happens is, with machine learning, you score and then you get your prediction. You really want to know that how good those predictions are. For that reason, you are looking into a model accuracy. Then you really know that your model is highly accurate, so it should be able to really predict a certain result. However, you really want to understand the prediction dependency on the inputs, and how that is, why this result is like that, why it is not why it is not other. So if you are trying to predict the house price and you got a result, you really want to know why it is that, why it is not something different. So for that reason, you really want to look into the explainability of the results, so you can understand that if you have the result, why it is. If you are using the image classification process where you have gotten a result of a certain class, you really want to know what are the reasons. So machine learning interpretability is actually open the black box of machine learning and make the results much more explainable. And reason and adding the reason to those results is a very important part of machine learning interpretability, because in a machine learning system there are various stakeholders. They may not be a part of the overall machine learning process, but they are related with the results, and in order to consume results, they really need to have the understanding of explainability of the results. So explainability, or MLI, is really give confidence to those who really wants to understand why the results are, and if they are such, what's the reason behind it. So it's basically explaining the why behind it. There are several techniques used for machine learning interpretability. LIME, which is really very popular, which can be applied for both supervised and unsupervised, is also work with neural networks as well as the statistical machine learning, and it really is very popular and used in so many ways in various machine learning algorithms, automated machine learning pipeline, and so on. So MLI explains the relationship to validate the results. So there are several techniques, understanding trees. If there are tree-based algorithms, if it's a linear regression, then it's really try to explain the results that way. It also uses a PDP, which is a partial dependency plots, and it also uses the feature validation, or sorry, the variable importance to really explain those results. So that is all about we have really gone through in this part, and here is the recap. So we understood various training specifics. We understood the supervised, unsupervised, and semi-supervised machine learning. We also understood the feature as well as the automated machine learning engineering and MLI in this section. I hope you have learned something from this presentation, and I hope you will be really getting ready to go into the technical part of machine learning after going through these three different parts of 10 concepts you really need to know about AI. I'm happy that you are here, and I really appreciate your time. So thank you so much.